7-element beam and you're operating them down the road with, you know, with a 0.5% efficiency antenna, it ain't happening. So really 17 is a good band. When it's open, it's as good as 20 and as good as and there's a CW portion of it, but generally I operate on 18-125. That's kind of what I have programmed, and that's usually my calling frequency, and that's about in the middle. 168, 18-168, I think is the high end. 165 is the high end of the band you can operate. It's not very wide, but there's lots of activity, and mobiles are generally welcome, and it's great. It really is. But again, that's your choice. Here's some these I found some efficiency versus length numbers, and I believe these are calculated rather than measured. And the guy started out with a 1.6 meter antenna, and then went from 1.6 to 3 and got different efficiency numbers, and then went bigger and bigger and bigger. And you can see that, like I said before, bigger is better and depends on the band. So, and again, these things, if anyone's interested in crunching the numbers, I can give you all this stuff on the phone or something. This is a comparison to the HF antenna that we did, that Rich and I did. This is my truck. I've got an aluminum toolbox on the back. I've got my antenna mounted on the left-hand corner. On the right-hand corner is my HF antenna. And one of the things that we found, as I mentioned before, that you really don't have any, you can't really get any gain antenna. Well, that's sort of true, but there's a caveat in that. When we did this, we wanted to find out what was there in fact or not a preferred direction of the vehicle. And what I did is I drove in a 360-degree circle while Rich was watching signals, and lo and behold, the maximum power on my vehicle from the antenna here is off the right front fender, which is the most metal, if you will, for the ground point. And it turned out to be about a 2 dB difference in signal strength by just pointing it in that direction. And I also mentioned to you before about bigger is better. On 40 meters, we did some tests, and we added an 18-inch length to the 40-meter antenna, and we got about a 25% increase in signal strength just by going 18 inches. A little bit more technical information. There were some, and we got some feedback from the article, and people were saying, well, your tests weren't valid because you want to do far fields, near field. So it turned out, and as I mentioned here, our test site was at Campo Beach, probably close to the real antenna range. And when we started this whole operation, because of 60-meter coil failure that I mentioned, and it just so happened that we had talked to a guy up in New Haven, which is about 30 miles away, and in what I feel, that's far enough field even on 60. So using his S-meter, we did some comparisons of antennas, and then when we did the final test for the article, we compared the same antennas, and it turned out that the numbers were very, very close to what we got with S-meter versus the more accurate scheme. Here's some efficiency numbers. Again, there's no magic bullet or magic cure to make a small antenna act like a large one. It all comes down to the current distribution, which is, you know, and here's some radiation resistance values for different bands, and you can see you get down on the low bands, it's pretty small. You get up on 20 meters, you get, you know, it's about, if you're trying to measure a 50 ohm system, that's, 2-to-1 SWR, but that's not bad. But down on the low end, 80 and 160, very tough mobile. Here's some information that I got, the dipole versus the mobile antenna. 80 meters, 133 feet. It's almost considered a perfect 100% efficient antenna. It's got a radiation resistance of about 73 ohms minus wire losses and so forth. Well, you try to operate 80 meters down in 8 feet. Radiation resistance, instead of being 73 ohms, is 0.1 to 0.5. And if you do simple calculation, you find out that all your losses, all of the power is getting dumped somewhere, and that's loss. Bad connection, ground losses. So the idea is to get the antenna as high as possible, get as much current you can in the metal, and this is where some modeling came in.
Excuse me, George, just go back to that
Sure.
for a second. Translating that to some of the antennas you see advertised, like the isotronic and whatever.
Well, you
does that
read all
have-
about these verticals that you don't need radials?
Right,
Well, that's a myth.
okay. I mean, does this, what, your findings carry to
Absolutely.
base station antennas that are short, extra
Well,
short antennas?
a short antenna, if you make a short antenna efficient, matter of fact, in this month's QSD magazine, there's an article in there, a guy wrote a very nice article for condominium stuff, and he's using 8-foot diameter loops.
But he's using a loop, yeah.
Using a loop.
Ground loop.
That's right.
I mean, a mag loop, sorry.
He's using a magnetic
Yeah.
loop, and they're very efficient, provided you can tune them. And you notice that he's using 1.5 or 2-inch diameter copper tubing because the R losses in those things are tremendous, and the voltages involved are unbelievable. So you got to use a 20 kV vacuum variable in order to tune it, and and all that stuff gets to be issues. But you get into short antennas. The point is that the problem is if you look at, here's some lengths versus radiation resistance and losses, and there's all. I mean, Fred is more into this sort of stuff than I am, but he can expound on it a little bit more. But short antennas just are tough to make work.
Okay, so when we see in the magazine some of these portable verticals that say they operate on 80 because they've got a loading coil, you're still talking about a real short length
Starting
of
a short antenna, and all the losses are losses, and they're all in the coil. Because if the antenna is short, that little short antenna's got to resonate at 3.5 megahertz. Now, either you put big capacitive caps on top, or put inductance in them to make them electrically long. And in order to get the inductance for that short antenna, it's got to be a lot of inductance. It's got to be small wire. Small wire is just inherently very lossy.
Okay.
George,
Sir.
on a calculated basis, this is all correct, but it shouldn't discourage anybody from
Oh, no.
operating 80 or 40. Years ago, I used to operate 80 in the county hunter's net, and driving between here and Philadelphia would work everybody across the country. Fortunately, radio is the dynamic range is very high, and even with the poor results that you're seeing there, there's no reason not to run 80 and 40 mobile. You can get fantastic results with
Yeah, but the problem that I found is like I did a fair amount operating on 20 meters. And it's very difficult to operate 20 meters to get anybody to talk to you because you're not going to put out a bodunk signal on 20. And unless you're 20 over 9, they don't want to talk to you. And 40 meters is okay, but as I mentioned before, there's a lot of nets that are happening. 80, and during the day for local stuff, I mean, you tune 80 meters from your home station, you really don't hear a hell of a lot. At night when the band gets long, you're hearing these megawatt radios, and to try to break in there with a mobile is tough. In the time that Paul was talking about, totally different story.
Remember I said the county hunter's net, okay, which is a controlled frequency and everybody gets a turn to talk. So it's not like you're competing with the kilowatts.
Right. See, there's very little of that going on. You can get on the 40-meter e-cars and you can check in, but there may be 200 people on it, and so you wait your turn. And I mean, I'm not sure if that's what I'm not sure what your idea of mobiling. And in mine is to get on and be able to chat with somebody driving from here to Saybrook or something. In my experience, I found that and from my experiences, 60 meters and 17 happen to be the bands of my choice. That doesn't mean anyone should change, but that's just my choice.
George, I found a couple of things. I started many, many years ago operating HF in the car, using the hustlers, the kilowatt coils, and I used it in the tri-band configuration.
With the spider.
Right, the spider.
Yeah.
It was very good. It was even good on 75.
Mm-hmm.
I was using a automobile custom cruiser wagon
What is many years ago?
30 years ago.
Okay, well, the Hustler quality, even though it still
Well,
has
that's
the
what I'm
name,
getting at.
that's the problem.
When I bought a new car one year, I bought 2 antennas.
Hustler.
Hustler. And driving along the first week, the mast snapped.
Great. That's
Or
right.
another mast, that snapped. I called Hustler. I told him I'm operating mobile, I'm having a problem because, well, you bend it down, and when you get where you're going, you put it up. I said, no, I'm operating mobile. He goes, yeah, when you get where you're going, you put it up. I said, I said, but all those years I've done it. And he said, well, in order to keep the price down, we had to make the material thinner.
That's right.
So I went to the Spider. The Spider was pretty good.
Yep.
It was aluminum, eventually it gave way.
Well, if you've been around that long, you remember Mastermobile.
Yes.
Well, they were good quality stuff. They were very
I
high
used
coils.
the band spanner.
Absolutely, great thing. Matter of fact, I went to the Hamfest, I saw, what was it, Nutmeg. And I almost bought it because I wasn't sure whether I was gonna give this thing or not. But if you remember, Johnson used to make that teardrop thing with 3 coils in it.
Yes.
It was one on a bench up there, the guy wanted $10 for it. I was
I
gonna
didn't
buy
see
it,
that.
bring it in and show you. That was a band switch.
But the other difference, now I'm using a tuner, a 706 with a tuner in the trunk and a 108-inch whip. It works fine up to 40 meters, or down to 40 meters.
That's right.
75 is
So all your power,
fantastic.
all your power is to being lost in the tuner.
It's a lot of power lost in the tuner, but the other thing is, I am now driving a Camry. There's not as much metal, and that makes it, the ground makes
Absolutely.
a big difference in
Absolutely.
the operation.
The fact that I showed you, and maybe I can go back here. Let me see. Oh yeah, here. The fact that I've got the feed point of the antenna about 4 feet off the ground, where typically on a mobile installation, you see it mounted on the bumper.
I've got it
or what-
mounted up on the trunk.
Exactly, and the higher you can get that current node off the ground and get more metal under it, because losses are what kill you in the mobile, because you're at a disadvantage. First of all, the 12 volts is a problem. If you look at all the modern solid state stuff for the home station, they're all running 48 volts, 60 volts, 80 volts. You know, back not too many years ago, an 80 volt transistor just didn't exist. Okay, so now they are. So they're running high voltage, being able to get lots of swing, lots of power. Very, very difficult at 12 volts. So everything is really critical. I mean, 3/4 of a volt in a 12 volt system on HF, at least on the 706, is worse than anything I found on voltage. It is very voltage sensitive. It falls on its face at about 11.9 volts.
Right.
It just shuts off. Sir?
Yeah, to continue what you were saying, one of the lead publications, Antenna Compendium number something or other, has an article in it by a guy who designs antennas for GE commercial, for the military. What he found, and this thing talked about, was a 14-foot whip with an antenna tuner. And the only thing that made a difference is exactly what you found, how much metal was on the vehicle.
That's right.
Everything else made absolutely no difference. Now for the commercial. I have in my attic a set of 30-year-old Hustlers, complete set, if anybody's interested.
Wow.
Kilowatt or regular?
No, I don't remember. They've been there a long time.
Matter of fact, when I had the trouble with the 60-meter antenna of the bad connection, I called Hustler and I told him about it. Well, so they put me in touch with some engineering techie, and I told him what the problem was, and he said, well, I guess we're gonna have to look into that. And I said, well, I had to cut my antenna apart in order to fix that. Now, what do I do? What he did is sent me a 12-inch length of 1.25 heat shrink tubing to put over it. Cheap. Thanks, Ken. Not a new antenna, but a piece of heat shrink tubing. But, you know, my point, believe me, I'm not trying to discourage anybody from doing it, because it is a challenge. It really is a challenge. For example, I was interested in field strength and line of sight and all that sort of stuff, and I did some calculations. There was some politicking that went on in the Norwalk repeater way back when, which we don't have to go into. So I'm pretty familiar with ERP on the Norwalk machine. I know where the antenna is. I know what the pattern is. I know all that stuff. So I plugged all those numbers into some calculations that I found, and figured out, based on the amount of power that Norwalk was running. And it turns out that Norwalk at that time was running 137 watts ERP. And based on that, the path to Stamford was 18 miles, figuring path losses and all that sort of stuff. And where I work down on Harvard Avenue, what kind of signal should I be able to get from the Norwalk repeater. And the calculation said somewhere about S6. My 706 was giving me S7, so that's pretty close, but that's line of sight. Now in the VHF world, you have to remember that you're running 20, 30, 40, 50, 75 watts. The antenna in Norwalk's case is 200 feet in the air. They're running 137 watts ERP. You're running 50 to 75 or whatever you're running. You're talking to a receiver that has about 1/10 of a microvolt sensitivity. If you can get 30 miles reliable communication from, and I'm speaking Norwalk because I live down there, that's pretty good. When you get into the HF world, all that stuff goes away because it's skip and it's ground wave and it's all that sort of stuff. So, different ballgame, but it is challenging, and there's nothing better. Oh, I gave up mobiling it because I destroyed my antenna, and I asked Jess, ND1L, who he goes up to New Hampshire to his daughters, and he goes to HRO quite a bit up there in Salem, New Hampshire. I said, hey, the next time you're up there, pick me up a ham stick, 17-meter antenna, because I destroyed mine, because I had a bridge with it. Sure. So he does that. Jess and I got together. I threw it in the back of my truck. So it was a Saturday or Sunday one weekend. I said, gee, let me try that thing. I unpacked it, put it on the back with, I use those Hustler quick disconnected QC connectors. Tuned it up, got the SWR right, tuned around on 17. I said, K1EHW Mobile, listen to me. A guy in Sweden came back to me sitting in my driveway. Okay, so you never know. You never, ever know. One other time I was talking on 17, coming from Stanford, I was dropping my truck off in Westport, and this is a gas station that had the oil change or whatever it was, and I was operating mobile, and I was talking to somebody, I don't know, Pennsylvania, wherever it was, 17. And we got talking about radios, and I happen to be originally from Cedar Rapids, Iowa, which is where Collins Radio was. And I actually met Art Collins. So the guy says, oh, really? Oh, Collins equipment, and all that sort of stuff. I said, you know, I really don't know whether Collins is in the business or not anymore, because they got bought up by Rockwell and so forth and so on. So somebody goes, break, comes in, they says, oh, that's just signal. I said, yeah, who's the breaker? No, I've been listening to your conversation of whether Collins is still in the business or not. He says, I am talking on a Collins radio. I just left San Diego. I'm at 42,000 feet going to Newark, and he's flying a private jet. He says, I'm talking to you on Collins radio. So I thought that was pretty neat. So, you know, that's what you can expect in Mobile. I've made, there was a guy that it was a guy from Rotterdam, and he was on a tanker from Rotterdam coming around through the Med, up through the Suez Canal, delivering this tanker up into somewhere, into Saudi Arabia or something like this. I talked to the guy 3 different days, Mobile on my way from, I was living in Wilton at the time, from Wilton to Stamford, 3 mornings in a row, and I actually followed him around and got the map, and it was interesting.
Back in the 70s, or?
No, this was a couple years ago. And another conversation I had in Mobile was with a guy that was in, he was in some little place in Africa, and it turns out the guy was originally from the States, and he was a monk or something or other, and he can only operate certain hours of the day because that's when the generator was running. So we chatted a little bit, and I said, well, you know, what's it like living there? He says, well, it's different. I says, well, in what way? He says, well, the delicacies are sort of interesting. I said, yeah, what are those? He says, well, our delicacy is monkey. And I said, well, what do you miss about the States? He says, damn it, a good old McDonald's hamburger. And that was Mobile. So, you know, you get into those things. So you throw away all of the hardships and the problems you have, but you get those things, and they're really, really worthwhile. They really are. So, anyway.
I used to have a QSO every night going home from work at between 1 and 2 in the morning.
Yep.
With a fellow in Ireland and a fellow in a block from the Kremlin.
Wow.
And this went on for months.
Yep. And it ends up being a camaraderie, because I got to tell you, operating Mobile, the true hams, and particularly, as I say, I stress 17 because The guys are there, everybody on 17 is operating pretty much the same. They do all of their operating basically with good antennas. Nobody runs kilowatts. So you get in there with a little mobile rig, they're willing to talk to you, really are, it's great. So, so these are some issues, and then again, the antennas, the 10 antennas that we used, they were not published because there were issues. The league decided not to. There's some efficiency numbers that I went, now I looked at some modeling, okay, and in a standard wire or Yagi antenna, the variables that you can plug in are the ground type and the height above ground. The rest of it's pretty given. You got a dipole, you got a Yagi, you got this, you got that, and you can model it. Standard ground-mounted vertical antenna, the variables there are the ground type and the radial system that you have. You can model that. It'll give you some idea of what's going on. In the mobile antenna, the variables are the ground system and the antenna type. There's very little wireframe data that I found. I did get a wireframe model from Llewellyn's EasyNet. I got it from Joel. Unfortunately, it has 580 segments. The freebie version, I found out tonight that Fred has the 5.0, which we can maybe get and publish, but I don't have the ability. It was $130 to buy that, and I just didn't have it. So that's some things that I found. And the final word, again, is to cut your losses, whether it be wire, antennas, antenna efficiency, fuses and fuse blocks, as they say. A couple other things that they're pushing some things about. I guess Dan, N1ZZ, did some high-powered mobile operation.